Finally for us here this evening, a diagnosis of Parkinson's disease can be among the most devastating that you can get from your doctor. The brain disorder gives people progressively worse shaking and motor skill deterioration that can eventually make it very difficult to walk or even talk. Right now, there is no cure, only treatments that can help control the symptoms. But a new study led by UB professor Jian Feng could be making steps to change that, focused on using stem cells to regrow the neurons that Parkinson's disease destroys. And Dr. Feng is here with us live now to talk about this. Thank you so much for taking the time. First off, I wonder if you can just explain to us what it is that you found here, keeping in mind that most of us don't have, medical degrees. I know it's probably very complicated, but in layman's terms, as best you can, what's the breakthrough?
Sure. I would like to thank you for the opportunity. So basically what we have found is a new way to make these neurons in a cell culture dish. We can actually now make human neurons from anyone, essentially. For example, we can actually get some skin cells or cells even flushed out from urine. As long as we have these cells, we can convert them into these stem cells, and then the stem cell can be converted into the neuron that are lost in Parkinson's. So there are many types of dopamine neurons. These are the neurons that make this neurotransmitter called dopamine, and the loss of these neurons cause the movement problems in Parkinson's. So we want to make these neurons in a culture dish so we can study them, so we can also actually develop therapies. Basically, what we have found is a new way to make these neurons that have all the property of these neurons in the human brain. So these are very unique cells in our brain. They make very long processes, and then these nerve branches, they're very tiny, but they're huge. They're like 15 feet in total length for a tiny cell. So they make sure that the brain receives lots of dopamine. And we are able to make these neurons to have all these nice properties. For example, they can control the release of dopamine in an auto feedback loop, and they can also constantly release dopamine. So these properties were never generated before in a dish, and we feel that we have the right kind of cells that we can use to study the disease and to make new therapeutic discoveries.
Dr. Feng, I know that there is a lot of excitement surrounding what you've discovered here. The question for people watching at home right now, suffering from this or with a loved one who is going through a Parkinson's diagnosis is, it's one thing, right, to find this in the lab like the one behind you right there, and it's another to apply it to a real world situation. That takes a lot of time, it takes a lot of research, I know it takes a lot of money. How do you see this moving forward as you take what you've found and eventually see it, how far down the road, making a difference in people's lives, you think?
Yeah, so that's a very good question. So basically, we have the scientific know-how. We know what to do to make the cells even better. We know how to make the cells. We can produce the cell. We can put them in therapy. We can basically, there are two possible uses for these cells. One is that we can use the cell to actually discover new compounds that people can take orally, for example, to treat Parkinson's. The other way is to basically put these cells in the brain of patients. We can try to see whether these patients can be cured of their motor symptoms. All these require a huge amount of effort, and it's really not. It's partly like a scientific issue, but more is really how we organize our society to pursue this kind of endeavor. It takes a lot of effort, it takes a lot of money, but I think that the society has lots of resources. I think the United States has lots of money, and money is not really a problem. It's really how you match money with talents so you can actually push things forward.
Well, congratulations on this. I know there's so much potential with it, and we're so proud to have brilliant researchers like you right here in Western New York doing this important work. Dr. Jian Feng, thanks for taking the time for us. We appreciate it.
Thank you very much for the opportunity.
You bet.